This table lists the instruction fields and formats for common instructions. So add has an opcode of 51, or in binary 0110011. Func3 is 0, and func7 is 0. And it's an R-type instruction. Branch if equal and branch not equal are both B-type instructions, and their opcode is 99, or in binary 11000011, and they only differ in their func3 field. So func3 is 0 for branch if equal, and 1 for branch if not equal, and so on for these various instructions. And you can refer to Appendix B for encodings for other instructions, for other RISC-V instructions. So we may want to also go the other direction. Instead of going from assembly to machine code, we may want to go from machine code to assembly, where we're interpreting, well, what instruction is that? And so we're going to follow this process. We're going to write the, typically it's given in hexadecimal first. So here's our hexadecimal instruction, our machine instruction. We write it in binary first, and we look at the opcode, and if needed, func3, to tell us how to parse the rest of the field, or what kind of format it is. So then we extract the fields and look at op, func3, and func7 fields to tell us what the operation is, and then we can convert it to our assembly language, or RISC-V assembly language. So here's our hexadecimal representation of an instruction, hex 401FE83B3. And so we're going to write that in binary first, 41FE83B3. And then first thing we do is look at these, the op code, which is the lowest 7 bits of our instruction. So we look at those, the op field, and then we also look at the func3 field. So we extract those and look at func3 and the opcode. So we look at those first, and it says, okay, well, op is 51. That tells us it's an R-type instruction, and func3 is 0. We know it's add or subtract, but now we also have to look at func7 to tell us these most significant bits here of the instruction, to tell us, well, is it add or subtract? Func7 in this case is 32, right? 0100000 is 32, so it tells us, hey, that's a subtract instruction. So now we know how to parse all of those fields, and we know what instruction it is. And the next thing we do is we can look at this other one, hex FDA48393. First look at the op code here, and in this case it's 19, and our func3 bits are 0. And so we know, we look up the table or in Appendix B, and we know that that is an add immediate instruction. So we know it is an I-type instruction. So we know how to parse the rest of these fields. And so now, after we've done that, we say, okay, well, we know this is R-type, so we put all of the bits into those fields, our opcode, RD, func3, RS1, RS2, write those into, from their binary to their decimal value. RS2, all ones, is 31. RS1, 11101 is 29. And RD is 7, 00111. And now we can write the equivalent assembly language for that. Subtract x7, x29, x31. x7, x29, x31. And you'll notice that these x7 is written first on the left, and here it's written on the right. x29 is written going from left to right, and here it's going from right to left in our machine code and our assembly code. Okay, we write RD, RS1, RS2, and here we write from, this is going from right to left, from left to right, and now we go from right to left in our machine code, RD, RS1, RS2. And same thing for the next instruction. We looked at the opcode bits, the 7 opcode bits and the function 3 bits, and saw that it was an add immediate instruction. So we now know what format to use. We know that we have the RD field here and RS1, and the immediate bits are in the most significant bits. And so then we write this into decimal, minus 38. This is 9. RS1 is 9, and RD is 7. And we have add immediate x7, x9, minus 38. So let's talk about how we address operands. That is how we indicate which operand we want to use. So we have register only, immediate addressing, base addressing, and PC relative addressing. Register only addressing is when operands are found only in registers. For example, the add instruction and the subtract instruction only have register operands. Immediate addressing is when some of the operands are found in the immediate field. So add immediate and or immediate are 2 examples of immediate addressing modes. Base addressing is for loads and stores. So the address of an operand is found by adding the base address and an immediate. So in this case, the base address is 0, and the immediate is 72, and the immediate is assigned immediate. In the store word, base address plus the signed immediate. PC relative addressing is used by branches and jump and links. So the operand in this case is the PC. The PC is being operated on. And the way that we figure out what the destination PC should be is by adding a constant, an immediate amount to the PC. And so it's called PC relative because the PC, the destination PC, is relative to the current PC. So in this case, here's a branch if not equal. So the PC is here, and L1 is, in this case, minus 2,908 bytes before the current PC, before hex EB0. We find that by performing this value, 2,908 instructions before, so we encode 2,908 or minus 2,908 in the immediate field